Welcome to the fifth lesson in session 4 on general form and standard form. General form of a conic section is read ax to the second plus by to the second plus cx plus dy plus f is equal to 0. When presented an equation in general form, we need to identify the conic section, then convert that equation into its appropriate standard form. Now, when given an equation in general form, the first thing we have to do is make sure we properly identify the conic section that we're presented with. So for a circle, the values of a and b are always equal to each other. Notice that a and b cannot be equal to 0. So an example of a circle would be x squared plus y squared plus 2x plus 6y minus 15 equals 0. Notice the linear terms in the constant have nothing to do with determining the conic section. It's all about the quadratic variables, x squared and y squared. So with a circle, x squared and y squared have to have the exact same coefficients as they do in this case, which is 1. 1 x to the second and 1 y to the second. That tells me we have a circle. In an ellipse, the values of a and b have to have the same sign, but they have different values. Again, a or b cannot be equal to 0. So here's an example of an ellipse, 2x to the second plus 3y to the second plus 8x plus 6y minus 7 equal to 0. And again, we're always looking at the quadratic variables to determine the conic section that we have. So here I have 2x to the second, 3y to the second. So a is 2 and b is 3. Those have coefficients have the exact same signs, but they have different values. So that tells me what I'm working with is an ellipse. Third is a hyperbola, where the signs of a and b will be opposite of each other. They can have the same absolute value, but they will be opposite of each other. And again, a and b can't be equal to 0. So here's an example of an ellipse, x squared minus 3y squared minus 2x plus 11y minus 7 is equal to 0. So notice x squared and negative 3y squared. They have opposite signs. So the fact that they are opposite signs tells me that we have a hyperbola. Positive 1x to the second, negative 3yx to the second. Lastly, we have a parabola. And the trick to identifying a parabola is that there's only going to be a single quadratic variable. Either going to be ax to the second or by to the second, but not both. So a will equal 0 or b will equal 0, not both. An example we have is 3x to the second minus 6x minus y plus 5 equal to 0. So notice in this case we have 3x to the second. So we have a quadratic variable in terms of x, but we do not have a quadratic variable in terms of y. That tells me what I'm working with is a quadratic equation that's going to create a parabola. Completing the square for both variables is necessary to convert equations from general form into standard form. Let's get to some examples. In our first example, we have x squared plus 2x minus y minus 15 equal to 0. So remember, looking for x squared and y squared. In this equation, all I have is x squared without y squared. So if I am absent of a y to the second power and I only have a single quadratic variable, that tells me that the equation that I have is a parabola. So I'm going to move the constant to the right side of the equation along with the term that contains y. I want to group my quadratic variable with its corresponding linear variable. So I want x squared and 2x together, but the y and the 15 I'm going to move to the other side. And I have to do that algebraically, so I'm going to add y and we're going to add 15 to both sides, which produces a new equation that's equivalent. X squared plus 2x equals y plus 15. Now I'm focused on the left side of the equation here, and I'm going to complete the square in terms of x. So in order to do so, I have to add 1 to both sides. Once I've completed the square, I can factor and simplify. So x squared plus 2x plus 1 factors to x plus 1 quantity squared, and 15 plus 1 gives me 16 on the right side of the equation. Lastly, I'm going to solve for y. So I subtract 16 to both sides. Now notice in this case I turned the equation over, so I wanted y expressed on the left side of the equation, but I still just subtracted 16 to both sides. So I have y equals the quantity of x plus 1 squared minus 16 equals 0. So as you can tell from just looking at the equation here, I have a parabola that's got a vertical axis of symmetry. This parabola is going to open up, and it's got a vertex at -1, -16. Next, we have 4x to the second minus 5y squared minus 16x minus 30y minus 9 equals 0. So looking at 4x to the second and a -5y to the second, the values of a and b are opposites of each other, so I know what we're working with is a hyperbola. So in order to complete the square in terms of x and y, I need to group them together. So I want the 4x to the second and the -16x grouped together. I want the -5y to the second and the -30y grouped together. And I need the constant term out of the way. So I'm going to add 9 to both sides and group the terms with x's and group the terms with y's. Now my next step is to factor before completing the square. So I notice my terms in x are both divisible by 4, and my terms in y are both divisible by -5. So I'm going to factor out the 4 and I'm going to factor out the -5 from their respective groups. Next, I can complete the square in terms of x and in terms of y. So notice doing so, I'm going to add 4 to complete the square. But that 4 is tucked inside the parentheses, and everything inside those parentheses is getting multiplied by 4. So the true value that I've added is 16. So I have to add 16 to the right side of the equation. And same thing, I'm going to add 9. 9 is the number that's going to complete the square for the trinomial. But everything inside those parentheses is getting multiplied by -5. So -5 times 9 is -45. So by placing a 9 there, what I've really done is subtract 45 to both sides of the equation. Now I'm ready to simplify, so I factor. So it gives me 4 times the quantity of x minus 2 squared minus 5 times the quantity of y minus 3 squared equals -20. Now remember, the equation of a hyperbola, similar to that of an ellipse, is always equal to 1. So in order to set the equation equal to 1, I have to divide the entire equation by -20. Now notice, dividing by a -20 is going to make my my binomial of y positive. So I'm going to write that first. And my binomial in terms of x is now going to be negative, so I'm going to write that second. So now the equation is going to be y minus 3 quantity squared over 4 minus x minus 2 quantity squared over 5 equals 1. So here we have a hyperbola. It's going to open, y is listed first. Y is the positive variable, so I know it's going to open up and down. And it's going to have the center at 2, 3. So all that information is taken from the equation after it's converted to standard form. So that wraps up our lesson. Good luck on the quiz and the test, and please email us if you have any questions.